Have you ever stepped outside on a calm summer morning and noticed that the air was perfectly still, only to feel a strong gust of wind a few hours later? Or maybe you've watched trees swaying during a storm and wondered what makes the air move with such incredible force. Wind is something we experience almost every day, yet most people never stop to think about what actually causes it. Is it simply air moving around the planet? Or is there a much bigger process taking place behind the scenes? The truth is that every breeze, every gust, and every powerful hurricane begins with one simple source of energy: the sun. The sun constantly sends enormous amounts of energy toward Earth. However, it does not heat every part of our planet equally. Some places receive much more sunlight than others. Areas near the equator receive sunlight almost directly overhead, making them much warmer than regions closer to the North and South Poles, where sunlight arrives at a much lower angle. But that's only part of the story. Even within the same city, different surfaces heat up at different speeds. Dark asphalt absorbs heat much faster than green grass. Dry sand on a beach becomes hot enough to burn your feet, while the nearby ocean often remains pleasantly cool. Forests, mountains, deserts, lakes, and cities all warm up differently throughout the day. Because the Earth's surface heats unevenly, the air above it also warms unevenly. Warm air behaves differently from cold air. As air heats up, its molecules move faster and spread farther apart. This makes the air less dense, meaning it becomes lighter than the cooler air surrounding it. Since warm air is lighter, it naturally begins to rise higher into the atmosphere, much like a hot air balloon rises because the warm air inside it is less dense than the cooler air outside. As this warm air rises, it leaves behind an area where there is less air pressing down on the Earth's surface. Scientists call this a low-pressure area. Nearby, cooler air is heavier because its molecules are packed more closely together. This denser air sinks toward the ground, creating what is known as a high-pressure area. Nature constantly tries to balance these differences. Air naturally flows from areas of high pressure toward areas of low pressure, attempting to equalize the pressure everywhere. This movement of air is what we call wind. In other words, wind is simply the atmosphere trying to balance itself. The greater the difference in air pressure, the faster the air moves. When the pressure difference is very small, we experience only a light breeze that gently moves leaves or cools our skin on a warm day. But when the pressure difference becomes much larger, the air accelerates much more quickly, producing strong winds capable of bending trees, creating massive ocean waves, or even damaging buildings. If you've ever watched a weather forecast, you've probably seen maps covered with lines surrounding areas marked with the letters H and L. The H represents high pressure, while the L represents low pressure. Meteorologists carefully study these pressure systems because they help predict where the wind will blow and how strong it will become. When the pressure lines are packed closely together, it means there is a steep pressure difference, usually resulting in stronger winds. But if air always moves from high pressure to low pressure, why doesn't the wind simply travel in straight lines? The answer lies in the Earth's rotation. Our planet spins once every 24 hours, and because of this rotation, moving air appears to curve as it travels across the Earth's surface. This phenomenon is called the Coriolis effect. The Coriolis effect causes winds to curve rather than move directly toward low-pressure areas. In the northern hemisphere, winds are deflected to the right, while in the southern hemisphere they curve to the left. This effect is responsible for the giant rotating weather systems that appear on satellite images. It also explains why hurricanes spin in opposite directions depending on which hemisphere they form in. Wind exists on many different scales. Some winds last only a few minutes, while others are part of global circulation patterns that continue throughout the entire year. For example, sea breezes occur because land heats up faster than water during the day. As the land becomes warmer, the air above it rises, and cooler air from over the ocean flows inland to replace it. At night, the opposite happens. The land cools down much faster than the sea, causing the wind to reverse direction and blow from the land toward the water. On a much larger scale, enormous global wind systems continuously move air around the planet. These winds help transport heat from the equator toward the poles, preventing tropical regions from becoming even hotter and polar regions from becoming even colder. Without this constant circulation, Earth's climate would be far more extreme, making many parts of the planet difficult for life to survive. Sometimes the atmosphere becomes unstable enough to produce extremely powerful storms. Hurricanes form over warm tropical oceans where huge amounts of warm, moist air rise into the atmosphere. As this air rises, more air rushes in to replace it, creating an enormous rotating storm powered by the heat stored in the ocean. Tornadoes, although much smaller than hurricanes, can generate some of the strongest winds ever recorded. Inside the most powerful tornadoes, wind speeds can exceed 300 miles per hour, or nearly 500 kilometers per hour. Despite the destruction that strong winds can sometimes cause, wind is also incredibly important for life on Earth. Many plants rely on the wind to spread their seeds and pollen, allowing forests and grasslands to grow and reproduce. Wind also carries moisture around the globe, helping clouds travel from one region to another and bringing rain to areas that need fresh water. Ocean winds create currents that influence marine ecosystems and even affect weather patterns across entire continents. Humans have learned to use the power of the wind for thousands of years. Ancient civilizations used sails to cross oceans and windmills to grind grain into flour. Today, modern wind turbines convert the kinetic energy of moving air into clean electricity that powers millions of homes around the world. As technology continues to improve, wind energy is becoming one of the fastest-growing sources of renewable power. Here's an interesting fact. Even though the air around us seems invisible and weightless, the Earth's atmosphere actually weighs about 5.5 quadrillion tons. Every time the wind blows, enormous masses of air are moving across the planet. Even a gentle breeze involves millions of tons of air slowly shifting from one place to another. So the next time you feel the wind on your face, remember that you're experiencing one of Earth's greatest natural balancing systems in action. That simple breeze has traveled because the sun heated different parts of our planet unevenly, creating differences in temperature, air pressure, and density. Combined with the Earth's rotation and the shape of our planet, these forces create the complex wind patterns that shape our weather every single day. Wind is far more than moving air. It influences our climate, powers renewable energy, spreads life across ecosystems, drives ocean currents, and shapes the weather we experience every day. Without wind, Earth would be a completely different world.